Here we have a problem on evaluating limits. Okay, let me take the given limit as it is. It is the limit extends to 0 e to the power 2x negative 1 over e to the x to power negative 1. Okay, so we can directly substitute the given limit for x. That is, we can plug in 0 for x into the function given over here. So when I do so, e to the power 2 times for this x, we have to plug in 0. Negative 1 over e to the power. So for this x also we have to plug in 0, negative 1. So at the top we get e to the power 2 times 0 is 0, negative 1, and so here e is a mathematical constant. So here a finite value is raised to the power of 0. So whenever a finite value is raised to the power of 0, its value is just 1. So we get 1, negative 1 over here, and so the same thing we have for this e to the power 0. So I'm getting 1, negative 1 over 0. So because here the 1, negative 1 is 0, and when I simplify this stuff over here, again I'm getting 0. So 0 over 0, what is it called? So it's called indeterminate form. So whenever we divide 0 by 0, it's called indeterminate form. So it should not be considered as a final answer when we evaluate a limit. Okay, so what I need to do when I get 0 over 0 like indeterminate form? So I just have to consider the step which comes right before where I have applied the limit. So this is the step I have applied the limit 0 for x. Just consider the step which comes before that. So in this step, what I need to do is I have to apply the L'Hopital's rule. So what is L'Hopital's rule? So L'Hopital's rule means I have to find the derivative of the numerator and denominator here separately. So usually when I find derivative of a function which contains a variable in both numerator and denominator, I'll be using quotient rule. But when I use L'Hopital's rule, I'm not supposed to use quotient rule. So I have to find the derivative of the numerator and derivative of the denominator separately. So once I'm done with the derivative, if there is any possible simplification, I have to do it. So once I'm done with the simplification, I can apply the given limit. Okay, so let's use the L'Hopital's rule. So by L'Hopital's rule, let me finish writing. So I'm just going to use L'Hopital rule. So in the step which we have before the one where we apply the limit. Okay, so limit extends to 0. I have to find the derivative of the numerator over here. So the derivative of e to the power 2x is the same e to the power 2x. By chain rule, I have to do further derivative for the exponent 2x over here. When I find the derivative of this exponent 2x with respect to x, what do I get? Just 2. So because whenever I find derivative of a product where one quantity is a constant, other quantity is a variable, I have to keep the constant term constant as it is, and I have to find the derivative of the variable alone. When I find the derivative of this x with respect to x, it will just become 1. So 2 times 1 becomes 2. So the derivative of 2x with respect to x is just 2. And negative, so what's the derivative of this constant 1? It's 0. So the derivative of a constant is always 0. So now we have to find the derivative of the denominator. What is the derivative of e to the x to the power? It's still e to the x to the power negative. The derivative of 1 is 0. So I'm getting limit extends to 0. 2 times e to the power 2x it can be done, and this 0 can be ignored. And in denominator we have e to the x to the power. Okay, now what we can do is we can apply the limit limit we have for x. That is, we can plug in 0 for x into the function over here. So then I'm getting 2 times e to the power 2 times 0 over e to the power 0. So I'm getting 2 times e to the power 2 times 0 is 0 over. So the value of this e to the 0th power is just 1. So I'm getting 2 times the value of this e to the 0th power is 1. And we can ignore this denominator 1, because whenever we divide a value by 1, we'll be getting the same value. So 2 times 1 is 2. So the evaluation of the given limit is 2.